In this screencast, I will demonstrate how to perform quantitative fault trees analyses in FASTEN. Quantitative analyses allow the computation of the probability of a top event given that we know the probabilities of basic events. In FASTEN, we use the XFTA fault trees analysis engine to compute the probabilities. The FASTEN package contains the XFTA binary in the directory External Tools. Here, you can find also a PDF containing the XFTA book, which is effectively a manual of XFTA. Let us suppose that we have already a built fault tree model which is made up of a top event. In our example, engine overheating. This top event is decomposed with the help of AND and OR gates until basic events are identified. Let us enhance the basic events with probabilities. We can do this by selecting a basic event in the diagram and in its corresponding inspector window, setting its specification. There are several possibilities to specify a basic event. The easiest way is to specify its failure rate, lambda. This specifies the frequency of occurrence of an event within an hour and has an exponential distribution. For example, the blocked pump event has a failure rate of 1 in 10,000 hours. The event, electrical power outage, has a failure rate of 1 in 1,000 errors. Let us assume that the power system is periodically tested and repaired. We can capture this by using periodic test as specification. Let us consider that there is a maintenance test performed once every 100 hours, and that the first test starts after 100 hours. For the mechanical failure, we choose a Weibull distribution in order to consider aging and wearing out effects of the mechanical components of the pump. We choose beta bigger than 1 for specifying the aging. Let us choose it to be 2. For the scale, we choose 2,000 hours, meaning that the failures will be clustered around 2,000 hours, the characteristic life of the mechanical components in our example. We choose the time shift parameter to be 0. We continue to assign failure rates to the basic events in the valve insufficiently open branch of the fault tree. Let us choose that command too late basic event has a failure rate of 0.001 failures per hour, and that the human error and quality management issues have both 1 failure every 100 hours. So far, we have specified various failure rates for the basic events. In order to perform the analysis using the XFTA engine, we need to define an analysis configuration, a XFTA script. We create a new root node by right-clicking on the model and selecting New FASTEN Root Node, Safety Models, Safety Analyses, and then XFTA script. A new root node is created with pre-filled commonly used commands. They can be changed later. We give a name to the script. On top, we have a short documentation of how to use the script. We can open the web page of XFTA by following the link. We choose the fault tree we want to analyze, the top event, engine, overheats for biting the binary decision tree, and the same event for computing the probability. We choose the mission time to be 1,000 hours. We start the analysis by pressing the right button on the root node and selecting XFTA, Run Analysis menu. In short time, the analysis is performed, and we will see the result in a window on the lower part of the screen. It gives us the probability that the top event occurs after 1,000 hours, the mission time. We can investigate in more detail the reasons for this result by analyzing the cut sets and their probabilities. In fault tree analysis, a cut set is a combination of basic events that, if they all occur, will cause the top event to occur. XFTA is able to calculate the probabilities of the top event occurrence associated to cut sets. For doing this, we need to enhance the script by adding the command print minimal cut sets. We select the top event and the same file, out.tsv, where the results will be appended. We set the mission time to be 1,000 hours. After running the analysis, We obtain the result enhanced with the information about cut sets and their probabilities. Minimal cut sets are printed sorted in decreasing order of their probabilities. Basic events inside minimal cut sets are separated by tabulations. We can investigate how a certain cut set is propagated to the top event by copying the text representing the basic events of the cut set, separated by space in clipboard, and then using an intention Alt plus Enter on the diagram and setting the cut set. The gates involved in the trace will be colored in red. We can disable showing the cut set propagation by using another intention. Not all commands of XFTA and not all options of commands are implemented as language constructs. In this case, we can use the arbitrary text command. We can write arbitrary text, which will be generated verbatim in the script. For example, the command to print the cut sets can be written as plain text. Thank you for watching. See you at the next episode.